this, right? See what we do. This is a proper question, right? See, 2-hydroxypropanoic acid, right? Draw the enantiomers. This is a proper past paper question. See, when you call as enantiomers are those which will be optical isomers, right? I go backwards. Optical isomers, okay, fine. Optical isomers are those which will be having a chiral carbon, right? Chiral carbon. If anybody has got a chiral carbon, right, means it will be having all four groups different, A, B, D, E, right? That's very simple, right? Not functional group. They'll be having all four groups different, right? Now come to the next part, right? If you see that when we see that in any optical isomer, we were to find out the chiral carbon. That's very important, right? The skill lies over here, that we know that optical isomers are mirror images to each other, right? Fine. Secondly, now if you have got a chiral carbon with all four groups different, right? All four groups different. That means what? That carbon is had got 4 electron domain, and it is what, 109.5 tetrahedral, right? That's thing you have to catch up, right? It's 4 electron domain and tetrahedral, right? This is very important, right? Now, if you draw a tetrahedral, how to draw this tetrahedral? This then in the 3D shape like this. We draw like this, right? And this angle is 109.5. This is the way we have to understand the tetrahedral. We draw like this. When you draw this dot is single line, that means that these two bonds are on the plane of the paper. And a solid wedge means is above the plane of the paper, right? A dotted wedge is below the plane of the paper. So this trick you have to know. Chiral carbon means all four groups different, means 4 electron domain, means 109.5. It is tetrahedral, right? This bit you have to know very well, right? Now go to the next part, right? If you see that when we have to draw this IUPAC naming, we have to draw the IUPAC naming. Probe, first we draw probe, right? 1, 2, 3, 4, probe. Now we have to number it. This is the trick you have to understand. Number it because 2 is given. So 1, 2, 3, 4. Now propanoic acid. When you have got two functional groups, now this is an interesting one. When you have two functional groups, alcohol and carboxylic acid, remember the carboxylic acid takes the upper hand, and this should be given the minimum number. This is very important, right? If you got two functional groups, this is very good example. If you got two functional groups, which gets the preference? Lion and tiger. Who gets the preference? The much more stronger one. So carboxylic acid gets the minimum number. So we draw the carboxylic acid over here. Now we draw the OH group over here. Now H, we fill up the H over here. Now we search for the chiral carbon, right? This trick will be very helpful. We search for the chiral carbon, right? Now in the chiral carbon, you're saying what? This is this a chiral carbon? No. Is this a chiral carbon? No. Is this a chiral carbon? Yes. This cannot be considered to be checked for chirality. Why? Because there are three hands, right? There are three hands, right? And chiral carbon needs 4 hands. There are 3 hands, right? We cannot take this, right? So this is a chiral carbon you're having, right? Once you get the chiral carbon, right? What we do? We have to do a condensed formula. This trick you know. We have to do a condensed formula. How to do the condensed formula? CH, and after that COOH. Then we have to do what? Then we have to make sure that we are this I draw, this I draw. Next is what is left? OH group is left. We draw the OH group in this way. OH, and we draw dot 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 as the C2H5, right? Fine. Now we draw what? We draw a mirror. See, here draw a mirror. What we do to we have to make sure that we are making a mirror image, right? So HOOC, draw the line, carbon, hydrogen. Then you draw the bold line, OH. Then you draw dot 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 C2H5, right? Is it clear? So that's a very important point you have to understand, that whenever we are drawing it, we have to first be very sure of to draw the opposite way of the IUPAC, name to the substance, and after that we are putting a mirror. After putting a mirror, what we are doing? We are drawing the two hands on the same plane of the paper, right? And this is a way. Best example is this, that if you see that in this structure we are getting what? These are the two structures we are having, right? There's a very important chance that this kind of question will be popping up, right? The other question is what? This type of question, right? See, you have been given this, right? Isn't it? So you have to draw the mirror image, right? Simply two planes, the same planes, and this is above the plane, this is below the plane, and just to draw a mirror, Simple. This part, this bit you have to master, right? So this is a portion of the enantiomers portion, right? Thank you so much, right?